This is the EdExcel GCSE 9-1 Maths paper 2 from the November 2018 series, and this paper is the higher paper. Question number 1. We've got a set of even numbers between 1 and 25. A is the set of numbers 2, 8, 10 and 14. B is the set of numbers 6, 8, 20, and C is the set 8, 18, 20 and 22. For part A, we have to complete the Venn diagram for this information. Well, here are the numbers between 1 and 25 which are even. Now the first thing we can do is find out which number belongs in A, B and C. Well, clearly that's 8. So 8 belongs to all of these. And then we can find out what goes in A and B only. Well, there's no numbers which are common to A and B only. What about A and C? Which numbers are common to both A and C? Well, there's no numbers which are common to only A and C. What about B and C? Are there any numbers common to both B and C? Well, we've got the 20 which is common to both B and C. So now, what would go in A only would be the 2, the 10, and the 14. What would go in B only? Well, that will just be the 6. What goes into C only? We have 18 and 22. So let's cross off all the numbers which have been used. We've got 2 which is used. We have 6 used. We have 8 used. We also have 10 used. We have the 14 used. We have the 18 used. We have the 20 used up. And the 22. So the rest of the numbers would go along the outside. So we have 4, 12, 16, and 24, which go on the outside. Here is the complete Venn diagram. Next, a number is chosen at random from this set. We have to find the probability that the number is a member of A and B. Well, we have in total 12 numbers, and of these 12, how many belong in A and B? Well, that is this 8. There's only one number that belongs in A and B. That's 1, so our probability is 1/12. Question number 2. Sean has information about the height in centimetres and the weight in kilograms of each of 10 rugby players. He is asked to draw a scatter graph and a line of best fit for this information. Here is his answer. Sean has plotted the points accurately, and we have to write down 2 things that are wrong with his answer. Well, the first thing that's wrong is the line of best fit does not satisfy all the points. What we should have is a line of best fit looking something like this. And now for the next thing that's wrong, if we take a look at the height scale, we've got 140, 160, 170. It's not going up by the same constant amount. And so the height in centimetres scale factor is not linear. Here we have a jump of 20, then we've got a jump of 10, then another 10, then another 10, then another 10. So it's not a linear jump between the points. Question number 3. BEG is a triangle, and A, B, C and D, E, F are parallel lines, and we have to work out the size of this angle X, giving a reason for each stage of our working. Well, what we can do to begin with is recognize we have 2 parallel lines and that co-interior angles add up to 180. So the angle ABE, which is this angle over here, this will equal 180 subtract the 110 that's given, and it turns out ABE is equal to 70. So we have 70 degrees here. And the reason for this is because co-interior angles add up to 180. We can now find the angle EBG, which is this angle here, recognizing that angles on a straight line sum to 180. So the angle EBG, that's equal to 180 subtract the 70 subtract the 35. It turns out the angle EBG is equal to 75. So I've got 75 degrees here, and the reason for this is because angles on a straight line sum to 180. And we can also do a similar thing here. We can find out what this angle is, the angle BEG. The angle BEG, that's equal to 180 subtract the 110 subtract the 25, and it turns out BEG is equal to 45. So I've got 45 degrees here, and the reason is exactly the same as before. Angles on a straight line sum to 180. And therefore, to find out the angle X over here, X is equal to 180 subtract the 75 subtract the 45, and it turns out we get X is equal to 60. So the angle here is equal to 60 degrees, and the reason for this is angles in a triangle sum to 180. Question number 4. Northern Bank has two types of account. Both accounts pay compound interest. With cash savings account, the interest is 2.5% per annum, and with shares account, the interest is 3.5% per annum. Ali invests £2,000 in the cash savings account, and Ben invests £1,600 in the shares account. For part A, we have to work out who will get the most interest by the end of the 3 years. You must show all your working. Well, if I take a look at the cash savings account, the amount we'd get at the end of 3 years, we've got 2,000 invested, and then I multiply this by the multiplier, which is 1.025, and I raise this to the power of 3. And so if we work out what this is, it turns out we get £2,153.78. And so therefore the interest, that's equal to 2,153.78 subtract 2,000, and it turns out the interest is £153.78. 78 pence. And if I take a look at the shares account, I've got £1,600 and my interest rate is 3.5% per annum, so my multiplier is 1.035, and I raise this to the power of 3. So if I work out how much I'm expecting to get at the end of 3 years, that would be £1,773.95. And so the interest that's equal to £1,773.95, take away 1,600, and it turns out the interest here is £173.95. So, who gets more interest? Well, Ben would get more interest. The 173.95 is greater than the 153.78. So therefore, Ben would get more interest. And now for part B. In the third year, the rate of interest for the shares account is changed to 4% per annum, and we're questioning if this affects who will get the most interest by the end of 3 years. Give a reason for your answer. Well, if we take a look at shares, we've got £1,600 invested, and for the first 2 years I've got 1.035 to the power of 2, and then in the final year I've got 4%, so I've got 1.04. So if I find out how much this is, it turns out we get 1,782.52, and so in this case the interest, that's equal to 1,782.52, subtract 1,600, which is 182.52. And does this affect who will get the most interest? Well, we can see then it's still Ben, and therefore it has no effect. Question number 5. The diagram shows a floor in the shape of a trapezium. John is going to paint the floor. Each 5 litre tin of paint costs £16.99. 1 litre of paint covers an area of 2 meters squared. John has £160 to spend on paint. Has John got enough money to buy all the paint he needs? You must show how you get your answer. Well, what we can do first of all is find out the area of the trapezium. The area of the trapezium, I've got 1/2 times by the sum of the two parallel sides. We've got 10 plus 16, and then I times this by the height of 7, and it turns out the area is 91 meters squared. Now, we know that 1 litre of paint covers an area of 2 meters squared, so with this we can find out the number of litres required. The number of litres required, well, we've got an area of 91. 1 litre of paint covers 2 meters squared, so 91 divided by 2, that tells us we need 45.5 litres. And now what we can do is find out the number of tins we require. We know that 1 tin has 5 litres of paint in it, and so the number of tins required, well, we've got 45.5, and then I'm going to divide this by 5. The answer is 9.1, which implies we require 10 tins. And so the cost of these 10 tins, we've got £16.99 for 1 tin. We've got 10 of those. So the cost is £169.90. Now he has £160 to spend on paint. And because the amount here is greater than the amount he has of 160, we can therefore conclude he does not have enough money. Question number 6. A is the point with coordinates 5, 9, and B is the point with coordinates D15, and the gradient of the line AB is 3. We have to work out the value of D. Well, the gradient, that's given by the change in y divided by the change in x. So, if I take a look at my y coordinates, I've got 15, take away 9, and for my x coordinates, I would have d take away 5. And I know that the gradient is equal to 3. So if we simplify, 16 take away 9, that's equal to 6. So I have 6 divided by d minus 5 equals 3. Multiplying through by d minus 5, we have 6 equals 3 times by d minus 5, dividing through by 3. D minus 5 is equal to 2, in which case we can conclude d is equal to 2 plus 5, which is 7. So d is 7. Question number 7. We have to write for part A the number 0.00008623 in standard form. Well, for standard form, that's when a number is written as a times by 10 to the power of n, where a is in between 1 and 10, and n is an integer. So if I have the number 0.00008623, I need to move this decimal place 1, 2, 3, 4, 5 to the right, and therefore I am left with 8.623 times 10 to the power of minus 5. And then for part B, we have to work out 3.2 times 10 to the 3 plus 5.1 times 10 to the minus 2 divided by 4.3 times 10 to the minus 4. Well, if we work out the value of this, well, what we can do is substitute this into our calculator. We have 3.2 times 10 to the power of 3 plus 5.1 times 10 to the minus 2 divided by 4.3 times 10 to the minus 4. And it turns out here we would get 7441979.07. And again, if we were to write this in standard form, bearing in mind for standard form we want the number to be of the form a times 10 to the n, where a is in between 1 and 10, we need to move this decimal place 1, 2, 3, 4, 5 to the left, Question number 8. We have triangle P which is reflected in the line y equals minus x to give triangle Q, and then triangle Q is reflected in the line x equals minus 1 to give triangle R. We have to describe fully the single transformation that maps triangle R to triangle P. Well, what we'll do is we'll first of all draw the line y equals minus x. Here is the line y equals minus x. So now what I need to do is reflect shape P in the line y equals minus x to give triangle Q. Well, here is triangle Q. And then triangle Q is reflected in the line x equals minus 1 to give triangle R. So here is the line x equals minus 1, and then I need to reflect Q in the line x equals minus 1 to give R. So if I do that, the shape I will end up with is this shape over here, R. We would have a rotation 90 degrees anti-clockwise with center minus 1, 1. Question number 9. Martin truncates the number n to one digit. The result is 7, and we have to write down the error interval for n. So if I've got numbers, say 7 and then 7.1, and then we could continue. We could have 7.5 and then other numbers like 7.99 and then other numbers as well. Then we've got numbers above 7 like 8 and then 8.2 for example. But the point is, when we truncate to one digit, what we want to keep is the 7, because we know that the result is 7, so our number should start off with the 7. So any of these numbers would be perfectly fine for us to truncate our number to one digit to 7. And so for the error interval, we could have numbers from 7 up to 8, but not including 8. Question number 10. Robert makes 50 litres of green paint by mixing litres of yellow paint and litres of blue paint in the ratio 2 to 3. Yellow paint is sold in 5 litre tins. Each tin of yellow paint costs £26. Blue paint is sold in 10 litre tins. Each tin of blue paint costs £48. Robert sells all the green paint he makes in 10 litre tins. He sells each tin of green paint for £66.96. We have to work out Robert's percentage profit on each tin of green paint he sells. Well, we've got yellow and blue in the ratio 2 to 3, and in total we know we have 50 litres. And so for each part we've got 50 divided by 5, which is 10. So we've got 10 litres for each part. And so for yellow we have 20 litres. For blue we have 30 litres. And so therefore that gives us the 50 litres in total. So we've got 20 litres of yellow and 30 litres of blue. Now we know that yellow paint is sold in 5 litre tins and blue paint is sold in 10 litre tins. So what we can do is find out how many tins of yellow we have and how many tins of blue we have, and then we can find out the cost of yellow tins and blue tins because we are given the price. So we have, if we consider the yellow, we have 20 litres in total of yellow, and if I divide this by 5, because it's sold in 5 litre tins, this will tell me that I require 4 tins, and the cost of this, I have 4 times 26, which is 104. So for yellow paint it costs £104, and for blue paint we have 30 litres in total, and we know that blue paint is sold in 10 litre tins, so if I divide this by 10, that tells me that I require 3 tins of blue, and the cost of this would be 3 times by 48, which is 144. And so for 20 litres it would cost £104 and for yellow, and for blue it would cost £144 for 30 litres. So therefore the total cost, we have 104 for the yellow, 144 for the blue, and it turns out here we get 248. So it costs £248. Now what does this represent? Well, we're mixing in blue and yellow, and it costs £248 for in total 50 litres of green. So for 50 litres of green it costs £248. Now Rob sells all the green paint he makes in 10 litre tins, and he sells each tin of green paint for £66.96. So what we can do is find out the cost of green tins for 10 litres. So therefore the cost of 10 litres of green, well, that will be 248 divided by 5. 50 divided by 10 is 5, which is why I'm dividing by 5 here. I'm scaling this down to 10 litres, and it turns out here I get £49.60. So this is the cost of 10 litres of green, and so therefore the percentage profit, that's equal to, well, I've got the 66.96, which is the cost, well, this is how much he sells for, and then I take away 49.60, and then I divide by 49.60, and then times by 100, and it turns out here we get 35% as our percentage profit. Question number 11. That in a restaurant there are 9 starter dishes, 15 main dishes and 8 dessert dishes. Janet is going to choose one of the following combinations for her meal. We've got a starter dish and a main dish, or a main dish and a dessert dish, or a starter dish, a main dish and a dessert dish. We have to show that there are 1,335 different ways to choose a meal. Well, if I consider choosing a starter and a main dish, then the total number of combinations I have here, we've got 9 times 15. So this is the total number I have for a starter and a main dish. Then for a main dish and a dessert dish, well, there's 15 mains, 8 desserts, so the total number of combinations, we have 15 times by 8. So we have 15 times by 8. And then for a starter, a main and a dessert, total number of combinations, we've got 9. times 15 times by 8. And so this will correspond to a starter, a main and a dessert. So for the total number of combinations, we add these together. And so working this out, 9 times 15 plus 15 times 8 plus 9 times 15 times 8, that's equal to 1305. And that's exactly what we wanted to show. Question number 12. For part A, we have to write 4x squared minus 9 over 6x plus 9 times 2x over x squared minus 3x in the form ax plus b over cx plus d, where a, b, c and d are integers. Well, what would all this be equivalent to? Well, the 4x minus 9, well, the 4x squared minus 9 we can rewrite as a difference of two squares. We have 2x plus 3 times 2x minus 3. And the 6x plus 9, we can factorise out a 3, so I've got 3 times by x plus 3. And then I am multiplying this by 2x over x squared minus 3x. Well, the x squared minus 3x, I can factorise out an x, leaving me with x times x minus 3. And on the top, I've got the 2x. So now let's see what cancels here. Well, over here we've got a 2x. The 2x plus 3 would cancel with this 2x plus 3. And so what we can also see is this x would cancel with this x. So I am left with 2 multiplied by 2x minus 3 over 3 times by x minus 3. And if we expand along the top and bottom, 2 times 2x is 4x, and then I've got the minus 6, and then I've got 3 times by x, which is 3x, and then I've got the minus 9. So what I end up with as my simplified expression is 4x minus 6 over 3x minus 9. And then for part B, we have to express 3 over x plus 1 plus 1 over x minus 2 minus 4 over x as a single fraction in its simplest form. Well, for the 3 over x plus 1, well, essentially what I really want is for me to have a denominator of x plus 1 times x minus 2 times by x. And to maintain equivalence with the 3 over x plus 1, I need to multiply the 3 by x minus 2 times by x, because this divided by this will give the 3 over x plus 1. And then I've got 1 over x minus 2. Well, to maintain equivalence, I've got this 1, and then I need to multiply by x plus 1, and then x, because the x plus 1 and the x's cancel, leaving me with 1 over x minus 2. And then I've got the minus 4 over x. Well, to maintain equivalence, I need to multiply by x plus 1, x minus 2. So if we simplify all this, well, I've got 3x times by x minus 2, so that is 3x squared minus 6x. And then I've got x times by x, which is x squared. And then I've got another x. And then here I've got minus 4 times by x plus 1 times x minus 2. Well, I've got the minus 4, and then I've got x times x, which is x squared. Then I've got minus 2x plus x, so that is minus x. And then I've got the minus 2. And along the bottom, I've got x plus 1 times x minus 2 times by x. So now, if we simplify all of this, I still have the 3x squared minus 6x plus x squared plus x, but then I've got minus 4x squared, and then I've got the positive 4x plus 8. And along the bottom, we still have the x plus 1 times x minus 2 times x. So, 3x squared plus x squared minus 4x squared is 0x squared. Then I've got minus 6x plus x plus 4x, so that is minus x. And then I've got the plus 8 with it. And along the bottom, I still have the x plus 1 times x minus 2 times by x. And so this is my simplified result. I can't simplify this any further. Question number 13. The diagram shows a circle and an equilateral triangle. One side of the equilateral triangle is the diameter of the circle, and that's what we see here. And the circle has a circumference of 44 centimeters, and we have to work out the area of the triangle to 3 significant figures. But what do we know about an equilateral triangle? Each of the angles is the same. I've got 60 degrees for each of the angles. So what is the diameter? Well, the diameter, that's equal to the circumference over pi. And so I have for my diameter 44, which is the circumference, over pi. So for each of the lengths, I have 44 over pi. And the area of a triangle, that's going to be given by 1/2 times by AB sine C. So I've got 1/2 multiplied by 44 over pi times by another 44 over pi times by the sine of 60. And so if I work out the area, I've got 1/2 times 44 over pi times 44 over pi times by the sine of 60. So it turns out we get 84.93, etc. So it turns out we get 84.9 centimeters squared given to 3 significant figures. So we have 84.9 centimeters squared. Question number 14. On the grid, we have to sketch the curve with equation y equals 2 to the power of x. We have to give the coordinates of any point of intersection with the axis. Well, here is the graph of y equals 2 to the power of x. It intersects the axis here at 0, 1. When x is 0, y is equal to 1. Question number 15. The equation of a circle is x squared plus y squared equals 42.25. We have to find the radius of the circle. Well, the general form of a circle is given by x squared plus y squared equals r squared. So r squared, that's equal to 42.25, and therefore r, that's equal to the square root of 42.25, which is 6.5. So the radius is 6.5 units. Question number 16. There are only red counters and blue counters in a bag. Joe takes at random a counter from the bag. The probability that the counter is red is 0.65. Joe puts the counter back in the bag. Mary takes at random a counter from the bag. She puts the counter back into the bag. For part A, what is the probability that Joe and Mary take counters of different colours? Well, here is a tree diagram representing the information. Probability of red is 0.65, so therefore the probability of blue is 1 minus 0.65, which is 0.35. And because the counter is put back into the bag, those probabilities for the second branches remain the same. Now what we want is the probability that we choose different colours. So the probability that we choose different colours, that's equal to, well, we could have the probability of red followed by blue, or we could have the probability of blue followed by red. So we've got 0.65 times 0.35 plus 0.35 times 0.65. And if I work out what this is, I get 0.455. Now for part B, there are 78 red counters in the bag, and what we have to do is find out how many blue counters there are in the bag. Well, the probability of 0.65, that corresponds to 78 red counters. So 65%, that would represent the 78 counters. And what we ultimately want to do is find out what 35% is equal to. That's the probability of blue. And we can do this by finding out what 5% is worth. So to find out what 5% is worth, well, I need to divide 65 by 13, and therefore the 78 divided by 13, that tells me that 6 counters are represented by 5%, and therefore for 35% I need to multiply by 7, so therefore we have 42 counters represented by 35%, and therefore we have 42. Question number 17. P and Q are two numbers such that P is greater than Q. When you subtract 5 from P and subtract 5 from Q, the answer are in the ratio 5 to 1. When you add 20 to P and 20 to Q, the answers are in the ratio 5 to 2. We have to find the ratio of P to Q, give your answer in its simplest form. So, first of all, if we take a look at the statement subtracting 5 from P and subtracting 5 from Q, we have P minus 5 to Q minus 5 equaling 5 to 1. And if we write this as a fraction, we have p minus 5 over q minus 5 equals 5 to 1. And so cross multiplying, we have 1 times by p minus 5 equals 5 times by q minus 5. So we have p minus 5 equals 5q minus 25. And so therefore, p minus 5q is equal to minus 20. Call this equation 1. Now let's take a look at the next statement. We have 20 added to p and then 20 added to q to give the ratio 5 to 2. So I've got p plus 20 to q plus 20. That ratio is 5 to 2. And so if we work out the fraction p plus 20 and q plus 20, that is equal to 5 over 2. And so if we cross multiply, we have 2 times by p plus 20 equals 5 times by q plus 20. So we have 2p plus 40 equals 5q plus 100, in which case we can conclude 2p minus 5q equals 60. We'll call this equation 2. And if we take a look at equation 1 and equation 2, we can see that they have the same number of q's and we've got the same sign. And so therefore, if we subtract the equations, if we do equation 2, subtract equation 1, 2p minus p, that's a single p, 60 minus minus 20, that is 80. P is 80. And when p is equal to 80, I can find out what q is. I have 80 minus 5q equals minus 20. 5q is 100. Q is 20. So I've got the value of p and q being 80 and 20 respectively. And so therefore, to find the ratio p to q, well, the ratio p to q, that's equal to 80 to 20, which is 4 to 1. So I have 4 to 1. Question number 18. The line L1 passes through the points with coordinates 4, 6 and 12, 2. The line L2 passes through the origin and has gradient minus 3. And what we have to do is, given that L1 and L2 intersect at P, is find the coordinates of P. Well, let's focus on line L1. We can find the gradient of the line, recognizing the gradient is the change in y over the change in x. So we've got the change in y, 2 take 6, and the change in x, 12 take 4. And so what we can see then here is the gradient is minus 1/2. And what we can do is use the fact that the equation of a straight line is of the form y equals mx plus c. So I've got, if I pick the point 4, 6, say, I've got my y coordinate 6, that's equal to m, which is minus 1/2, times by x, which is 4, plus c. So I've got 6 equals minus 2 plus c. C is equal to 8. And so therefore the line of L1, we have y equals minus 1/2 x, which is the gradient, plus 8. And if I take a look at the line L2, we have y equals, well, the gradient is negative 3, so I've got y equals negative 3x, and it passes through the origin, so we add on plus 0. So I've got the equation of line L1, y equals minus 1/2 x plus 8, and the line L2, y equals minus 3x. We now need to find out where they intersect, so if I call this equation 1 and this equation 2, we can set equation 1 equal to equation 2. So I've got minus 1/2 x plus 8 equals negative 3x, times through by 2. I've got minus x plus 16 equals 6x, negative 6x. So if I add 6x to both sides, I have 5x equals negative 16. So x is equal to negative 16 over 5. And from this we can find out what y is. Y equals negative 3 times by negative 16 over 5, which is positive 48 over 5. So the coordinates of P then, we have negative 16 over 5, and we also have 48 over 5. These are the coordinates. Question number 19, we have to solve 22, which is less than m squared plus 7 over 4, which is less than 32. We have to show all our working. Well, if I multiply through by 4, that means I have 88, which is less than m squared plus 7, which is less than 32 times 4, which is 128. Now, the way we can solve this is to treat this as two separate parts. We've got the 88 being less than m squared plus 7, and we also have the m squared plus 7 being less than 128. So there's two parts which we need to solve. So if I focus on the 88 being less than m squared plus 7, well, subtract 7 from both sides, so we have m squared is greater than 81, m squared subtract 81 is greater than 0, so we have m minus 9 times m plus 9 being greater than 0, so we have m, which is, well, if I think about my sketch of my quadratic, I've got minus 9 and 9, and I'm looking at where the graph is greater than 0, so that's here and here. So I've got a solution of m being less than minus 9 and a solution of m being greater than 9. Now let's think about the m squared plus 7 being less than 128. Well, m squared will be less than 121. M squared minus 121 is less than 0. So if I factorize, I've got m plus 21, rather, m minus 11 times m plus 11 is less than 0. And if I think about where the solutions would be on a number line, I've got minus 11 and 11 over here. So I've got m being between minus 11 and 11. So now I need to find the value of m which both of these solutions are satisfied. Now the way we can do this is to draw a number line. So here is my number line. I've got minus 9 here and minus 11 here, and 9 here and 11 here. Now I've got a solution, m is less than minus 9. So if I show that on my number line, here is that solution. And I've also got m being greater than 9, so that would imply I've got a solution here. And then I've got m being in between minus 11 and 11, so that would be somewhere between here and here. So the solutions I want then would be in between these values over here. So I've got a solution in between minus 11 and minus 9. So I've got minus 11 being less than m being less than minus 9. And I also have another one over here in between these two values here, between 9 and 11. So these are my solutions. Question number 20. Here is a frustum of a cone. The diagram shows that the frustum is made by removing a cone with height 3.2 centimeters from a solid cone with height 6.4 centimeters and base diameter 7.2 centimeters. The frustum is joined to a solid hemisphere of 7.2 centimeters to form a solid S shown below. The density of the frustum is 2.4 grams per centimeters cubed. The density of the hemisphere is 4.8 grams per centimeters cubed. We have to calculate the average density of solid S. Well, what we need to do before anything else is find out the diameter of the smaller cone. The height of the larger cone is 6.4. The height of the smaller cone is 3.2. And so the length scale factor is equal to 6.4 divided by 3.2, which is 2. So to go from the small cone to the large cone, we multiply by 2. And so if we have the large cone having diameter 7.2, that means the diameter of the smaller cone is 7.2 divided by 2, which is 3.6. So we've got 3.6 centimeters. Now, what we can do is find out the volume of the big cone and also the volume of the small cone and then subtract them. And we know that the volume of a cone is given by a third pi r squared h. So the volume of the big cone we have the volume of the big cone equaling 1/3 pi times by, well here, the radius will be half the 3.6, or rather the half the 7.2, which is 3.6. So I've got 3.6 squared times by the height of it, which is 6.4. So let's work out the volume of the big cone. I've got 3.6 squared times 6.4 divided by 3. So it turns out I get the volume of the big cone equaling 27.648 centimeters cubed. We can also find out the volume of the small cone. The volume of the small cone, we've got 1/3 pi, and the radius here will be half the 7.2, rather half the 3.6, which is 1.8. Then this is squared, and then I times by the height, which is 3.2. So I've got 1.8 squared times 3.2 divided by 3, and it turns out the small, well here, rather I've got pi with it. The volume of the small cone is 3.456 centimeters cubed times by pi. And therefore what we can do is find out the volume of the frustum. The volume of the frustum, that's equal to 27.648 pi minus 3.456 pi. So I've got 27.648 minus 3.456, and it turns out we get 24.192 pi centimeters cubed. So now that I know the volume of the frustum, I can now find out the mass of the frustum. Well, before we do that, let's find out the volume of the hemisphere. The volume of the hemisphere well, I know how to find the volume of a hemisphere. That's 4/3 pi r cubed. But that's for a full circle, so for a hemisphere I would have half of 4/3 times pi. Now the radius here will be half of the 7.2, which is 3.6 cubed. So if I work out what this is, I've got 3.6 cubed times 4/3 times a half. So I get the volume of the hemisphere equaling 31.104 pi centimeters cubed. So I've got the density given of the frustum and the hemisphere, so now I can multiply the volume by the densities to find out the mass. So the mass of the hemisphere I've got the density, which is 4.8, and I multiply this by the volume, 31.104 pi, So if I have this 31.104, if I times that by 4.8, it turns out I get the mass being 149.2992 pi grams. And we can also find out the mass of the frustum. The mass of the frustum, I've got the density 2.4 grams, and I've got the volume, which is 24.192 pi. So if I work out what this is, I've got 24.192, which is the volume, and I'm timesing this by 2.4. So it turns out we get a mass of 58.0608 pi grams. So now that I know the masses, I can find out the total mass of the solid, and I can also find out the total volume as well. So if I find out the total volume first, well, to find out the total volume, I need to add together the volume of the frustum, 24.192 pi, to 31.104 pi, and if I work out what this is, it turns out I have 55.296 pi. So that is the total volume, and the total mass, that will equal 58.0608 pi plus the 149.2992 pi. So it turns out the total mass is 207.36 pi grams. And now we can find out the average density. We can do this by the total mass divided by the total volume. So I've got the total mass 207.36 pi grams, and the total volume 55.296 pi centimeters cubed. So therefore the average density, pi's cancelled, so I've got 207.36 divided by this. So it turns out we get 3.75 grams per centimeters cubed. So we have 3.75. Question number 21. A, B, R and P are 4 points on a circle with centre O. A, O, R and C are 4 points on a different circle. The two circles intersect at the points A and R. C, PA, CRB and AOB are straight lines. We have to prove that the angle CAB, so the angle CAB, which is this angle here, and the angle ABC, so ABC that's here, we want to show that those are equal. So this is the goal of the question. So first thing we can do is join up the points O and R, and from that we can actually see that OR is equal to OB, and that's because they are both radii. And so because we've got these being radii and them being equal, we can therefore conclude we've got a isosceles triangle. Now if we let CAO equal x, so if we let the angle CAO equal x, then the angle CRO, which is this angle here, if I write that down, the angle CRO, that will equal 180 minus x. So this angle here is 180 minus x, and the reason for that is I've got this circle and I've got opposite angles in a cyclic quadrilateral, and we know that those add up to 180. So we know opposite angles in a cyclic quadrilateral sum to 180. And then what we can do is find out the angle ORB, which is this angle here. So the angle ORB, that will equal 180 subtract the angle CRO, which is 180 minus x. And it turns out here we get x. And so this angle here is x, and that's because angles on a straight line sum to 180. So I've got x over here, and because I've got an isosceles triangle, I can therefore conclude that the angle OBR is equal to x, and that's also equal to the angle ORB, and that's equal to x. And that's because of this reason here, where ORB, the triangle ORB, is isosceles. So I've got x over here, and from here what we can say is, as OBR is the same thing as the angle ABC, and the angle CAO, which is the same as CAB. So this is from the diagram. Because this angle is x and this angle is x, we can therefore conclude that CAB is equal to ABC, which is equal to x. And that's exactly what I wanted to show.